Okay, now that you're now back, just before we continue further our very interesting, I should say, journey into the Bayesian analysis, and at this particular stage about the Bayesian model comparisons. Now, we just want to talk about one very interesting concept that it's going to be a cornerstone of our future tutorial analysis, and that's going to be we just want to talk about a kind of a measure. We're going to talk about the measure, but what type of the measure that we just want to talk about then? The measure that we just want to talk about for this tutorial is going to be something which it shows the predictive accuracy, which is going to be the predictive accuracy measure of your model. That's the thing we just want to do. We want to come here and talk about the model that we have just created. For example, the model that we are just going to talk, for example, as an example. For example, the thing that we have talked about so far, it was the model that we just used to just use a Bayesian regression analysis in order to just predict the women's heights from their weights in a data set which was an internal data set into our environment, and it was called, I should say, the women data sets. For example, the model, it can be that one for our illustration purpose, but for your own case, it may be any model that you have used for your research, then any linear or non-linear Bayesian regression model that you're trying to fit that in your data sets, and now that's the stage you just want to measure some kind of characteristics of your model, which is going to be about the accuracy that your model is going to produce. However, at this part of the tutorial, the measure that we are just going to get focused on that, it's going to be somehow related to some kind of a predictive power of your model then. But what do I mean by the predictive model? Imagine that, for example, you have in the model that you're looking into, the thing that we just worked so far was that we said that, okay, the model is going to be, let's call that y, is going to be a function of, let's say, for example, as that's the thing which we have done so far in the multi-linear regression analysis. We said that we include then intercepts. Then we just come here and talk about, I should say, another the variable. We just call that x, which I can be ranged from 1 to n anything. And we say that in the model that, for example, that we're looking into, we have two type of the models. We have one, I should say, this is going to be the y, which, as you have noticed, that we call that a kind of a response variable. And the thing which you have noticed so far is that for the x, we call that a kind of a predictor. Because that's the thing that by using of, I should say, the slopes, that just we're going to just make an inference about. And also for the intercepts, we are just going to predict the response variable. At this stage, we come here and say that, okay, imagine that we have, let's say, we have one, let's say, the response variable y, which we have looked into that based on the model that we have been able to just come, for example, from here. For example, this model, which we just got a value for the y, based on the inferences that we just made for, let's say, all the coefficients of the model. We said that we have just made an observation. For example, we have one y. However, the interest that we are just going to have is that if we are going to be able to just move from the y which we have already have in our data sets, if the model is being able to, let's say, for example, make some predictions of the y, and that's what I call that the y hat, the hat which I have chosen to be on top of, I should say, the y here. It shows that it's going to be some kind of a future value. It's going to be a kind of a future value of the model which I have created over there right now. And that's going to be the thing which is going to be my focus for, let's say, for this, for example, for this part. I ask myself, what happens that, for example, from the response variable which I have, it can be, for example, imagine it's going to be the temperatures, or essentially for the model which we have worked so far, for example, it's going to be, let's say, the height of the women's, which we already know in our data sets. Is it possible, for example, the thing that we talked about so far was that, for example, I do not want to digress a lot, but let's go to move to something very interesting. Imagine that the woman that we had, I should say, if you remember, we had 15 women in our data sets. And we said that imagine that each woman which we have here, it's going to be essentially 15 one. We have an understanding of their weights and their heights. For example, if it's going to be their weights and it's going to be their heights, and we know everything about them. But imagine that, what happens that if we had totally 15 women as an index in our data sets. Imagine that if there is another woman, that woman is going to be the 16th woman, which is going to get inside the realm of these already 15 women which we have, but we know the weight of the 16th woman. Is it possible that also we get an understanding that how much is going to be her height? Essentially, that's essentially what did I mean here when I talked about, for example, in the model which I had here, I said this one. I said we have the y, it's going to be the, for example, the woman's height, which we already know about that, and it's going to be the y hat is going to be the height of the 16th woman who is going to enter into the realm of these 15 women which they are already there. And we know about their weights and we know about their heights, and we use them in order to just make the model there. In order to just do that, we have, I should say, a kind of symbol notation, which we say that, okay, we say that we just put that inside these parentheses. The one which we already know, it's going to be on the right side of this perpendicular line, and the one which we are just going to be, we are going to predict that it's going to be on the left side with the hat side. Then we just say that, okay, because the thing in the Bayesian, everything is going to be probabilistic. We said that, okay, what's going to be, let's say, the P as in terms of, I should say, the probabilistic thing that we have, let's say, we have talked about it. Okay, this one, then that's the thing which said that. We said that, okay, the probability, if we just want to interpret that, we say that it's going to be said that, okay, what is the probability of finding this value as the woman's height if we already know the height in, or should say, in our data sets. For example, from the previous data which we had, we know the weight, the height of the woman, which is said that what's the probability of the 16th woman height is going to be this, given we know that, for example, what is the y of, let's say, the 15th woman then. And that's the thing that we are just going to talk about that. We're going to associate something with these kind of types of the things that we say. We call that a kind of a predictive accuracy measure. We said that we are just going to assign something to this stuff as a kind of a predictive accuracy measure. Okay, now, in order to just find the formulation within the context of the thing that we just want to do, we are just going to, it was essentially a kind of a preface to what do we mean by a predictive accuracy measure. But for our case within the, I should say, the Bayesian framework, we are just going to become a little bit more focused and specific. We come here and say that, okay, imagine that the probability that we said, it's going to be, I'm just going to start from small point of, I should say, our model, then I expand it to include everything. Imagine that we have n data sets. If we have a data sets or we have a population, which it has, it's fair to say that we have a population that it has n observation. For example, in our case, for example, as we have worked so far with it, we had a population of 15 American women that we know their heights and weights. Imagine that n is going to be 15. We say that, we already talked about this one. The probability of a prediction that we make given the observation that we have made. That's the thing which we talked about on the previous slide. However, we know that the probability, it's always something between what? Between 0 and 1. We do not have a probability. That's the basic thing that we always remember that from, I should say, even the data management course from, let's say, the high school session, grade 12, that the probability is always a number which stands between 0 and 1. It can be 0 and it can be 1, and it can be somewhere in between, I should say, that interval, but it can never goes above and beyond those two, I should say, interval, going greater than 1 or less than 0. Then if we just put then the log, if you take the log of that value, then you can expect that, for example, we have the log of the probability based on the laws of the logarithms. You see that if you have a probability, for example, you know that if you have a log of, let's say, for example, if you have a log of the x, which you know that the x is gonna be less than 1, then you see that, for example, your log of the x can be also negative. That's the thing that we have seen that. If it can be 1, you know that the log is going to be 0, but if it's less than 1, you know that the log of that value can be a negative number. And that's why we just see that if we just put that, for example, if you put, let's say, for example, the log of the probability, you expect that to have something, for example, either a 0 or something negative. That's going to be so far of this. We imagine that, for example, in our population, which is 15 number, we are just constructing this. And imagine that at the same time, because you are just going to make a kind of an observation, we have a new data sets. For example, imagine that we are going to have, I'm just going to go to give our example once more again here. Imagine that it's going to be our women population. On the data sets that we have already worked with that so far. For example, we have 15 women. N is going to be 15 women inside, which we are sure what is going to be their height, what is going to be their weight. And now imagine that we have another population of these ones. I'd say that, for example, a new data sets, new women, which is going to, let's say, for example, have, let's say it can have a variety of the population inside, which we said that its n can be anything. N can be, let's say, 13 women, which they are just going to enter our population, and that's why we are just going to look into the predicted heights then. That's going to be the thing then. We have no inference about the new woman, but we know everything about based on the model which we have created. We have made some inferences about the slopes and the coefficients of the model in a regression Bayesian. We know that, for example, we have some uncertainty, but we have a good understanding of what's happening inside this woman, which we already have. Imagine that these predictions comes from this population that I have. From this population, that it has, let's say, 13 women inside. Okay, I'm just going to go ahead to just find point by point. Look at this terminology, which I'm just going to use. I'm just going to say that it's going to be point by point, which we can come with the terminology. We say that it's going to be a point-wise prediction. Then I say that for each new woman, which is inside the new woman data sets which I have, which I indexed from I equal to 1 to 13, I create this log here for each woman. Then essentially, you say that, okay, if I also come, let's say, with another probability, that I say that the probability of, let's say, having the prediction with the I is going to be this. That's the thing, for example, it's going to be your, let's call that, you cannot call that a kind of a prior time, but it's going to be some kind of a probability that we do not know about that still. We are just going to make some inference about that. That, for example, the P is going to be the probability that, for respecting the height of that woman. However, we are just also a conditional one on the data sets we already know, on these old woman data sets which we had. And now, because we are doing point by point, or point-wise, I should say, estimation, you see that when we are just multiplying them together for 1 point, now we have 13 points in the new data sets. In our prediction quest and journey, then the thing which we do is that, okay, we have point-wise, now we have 13 values which is multiplied together in terms of prior-wise, for example, prediction, probability of the prediction with its log probability. Then, okay, we say that the best thing is that we just add these 15s together, 13 new predictions together, which is going to be I from 1. It can go to the n, which is in our simple data example which we have here. The maximum thresholds for the n is going to be 13 women because we have 13 data sets in the new data sets population in order to just make the inference on the prediction then. Okay, that's going to be this. And however, we are just going to do something as a final touch for the derivation of this model, and we say that, okay, now we have also, we are just going to, in case if we get a numerical value, we are just going to, add all those values together, because every probability that you multiply into the log probability of a conditional probability, it's going to give you a value when you add them together. Then we just say, okay, we just come here to integrate them. Theoretically, it doesn't make sense, for example, very reasonable to you that why do we, for example, integrate? The thing that we are just going to do is going to be a kind of a complete theoretical, and we said that the integral which you get, we are just going to get a number, and we call that number a kind of a ELPD. Okay, and this ELPD, which I'm just going to say in a minute, that what it stands for, it stands for expected log probability density, which this one is essentially the measure for the predicted accuracy of our model. Let me then just go to the next page. I'm just going to write it here. We said that the ELPD, it's going to stands for expected. It's a complete theoretical number we assign to the model log probability density. And as you saw that, it's going to be, let's say, for example, we have a sigma of, let's say, of the probability of our predictions on the value times the log probability of our predictive probability for each new data sets, y times, let's say, d of y, which it shows that we have to just have also an integral, and n is going to be the number of the population, and that's going to be called the ELPD. That's the thing which we derive, and also that's going to be essentially at the end, that's going to be a measure for predictive accuracy of our model. Okay, and now essentially that's the thing, this is the thing that we derive. We tried to essentially connect piece by piece based on the examples, for example, which we had from the back slide that we had. We said that, for example, we have the new data sets wants to enter the old population, then we try to build from, I should say, the basic prediction value for the y to go to, let's say, the theoretical format of the expected log probability density as a theoretical measure for the predictive accuracy of the Bayesian model that we have just created so far. It's going to be the thing on the next tutorial. When we just come back, we are just going to go ahead into R and check the model that we have had to see that, for example, in order to compare the models, what is going to be, let's say, for example, the ELPD in action into the real environment with the real data sets with the real situation then. The thing that we discussed now, it's just the theoretical framework. Then when on the next tutorial, we just go in the real data sets, and if we find a measure for the ELPD, we understand what do we mean actually when we talk about the expected log probability density. Okay, stay tuned. On the next tutorial, it's going to get so much fun because we are just going to see these theoretical stuff into the real world and the real data sets.